Okay. Going back to where we were before the exam. And I'm going to do a little bit of repetition here to start because that was Wednesday. Nobody's thought about that since Wednesday. And this is something that kind of gets rusty even at the best of times. But remember, just before the exam, what we were talking about was the general power rule. And what it looked like was, instead of having just x to a power, we had an expression raised. Ooh. Let me do a couple. Hello. Let me do a couple of things here. Okay. So we had 3x plus 5 to the 8th power instead of just x to the 8th power or something. And before I just write the formula up here, I want to remind you about how this worked with an example. You don't need to write this example down. You have these examples from last week, some that are similar. But for instance, if our function, and I'm going to pick a fairly straightforward one, was 5x plus 4 whole thing squared. Well, we already said for a square, I might not even need a new formula for this. If I FOIL that thing out, I'm going to get 25x squared plus 40x plus 16. I'm just going to write them side by side. I'm going to do the FOIL method. There we are. And so I know the derivative of this guy needs to be 50x plus 40. Done. I don't need a new formula for that. But when we talked about the general power rule with this kind of problem, remember what we tried was doing this just like the power rule. So we said, look, I'm going to bring the exponent down in front, and I'm going to subtract 1 from the exponent. So in this case, and I'm going to get off the bottom here in a second, but I want this all on one page. So the 2 would come down in front, we'd subtract 1 from the exponent. But notice that doesn't get us the right derivative. That was the whole point we discovered last Wednesday, or last Monday, in fact, because we reviewed on Wednesday. If that's all I do, what I used to do with the regular old power rule, I don't get the right derivative. I'm supposed to get 50x plus 40, and I'm getting 10x plus 8. And so what we said last Monday is, that's not how the general power rule works. It starts that way, but in order to turn this into this, the correct answer, what do we need to multiply 10x plus 8 by? Now we agreed that we need to multiply by 5. So there's a missing 5 here to get us the 50x plus 40. And where is this 5 going to come from in terms of this original problem? It's the derivative of what's in parentheses. It's the derivative of the stuff. So when we wrote the general power rule, we said, look, it starts like the regular power rule. Exponent down in front, keep whatever's in parentheses, and subtract 1 from the exponent. And then we have to multiply that by the derivative of whatever is in parentheses, what I'm calling stuff. And so there are 3 pieces to that derivative of expressions raised to a power using the general power rule. So if we had g of x is 2x plus 1 cubed, and we didn't want to work this all the way out, because I don't want to do 2x plus 1 times 2x plus 1 times 2x plus 1. I could do that, but I'm probably not going to need that for what we're going to do with these guys. according to the general power rule, what three pieces would I get when I took the derivative here? What would my derivative for this guy look like? I'm going to multiply anything out just yet.
Three.
Exponent down in front, so I'd have a 3.
In parentheses, 2x plus 1.
Now squared.
And then you multiply that by 2.
Okay, so that's exponent down in front, stuff, subtract 1 from the exponent, multiplied by derivative of stuff. And it may be that that's all I need to do with that. I may not want to multiply anything together, but we need to talk about what you can multiply together, because sometimes you'll want to. Sometimes people will want you to. And what you can't. And even if we weren't going to multiply this together, there are always going to be people who do want to multiply something, and we need to make sure you know what you can and can't do. Right? This is all multiplication. So technically, order doesn't matter when you multiply. You know, 3 times 5 times 7, or 5 times 7 times 3, or 5 times 3 times 7. Those are all going to get you the same answer, because you're going to multiply, you know, 2 of the numbers together and then the other one. So back up here, if we wanted to, and we're going to prove this in a second, and this is the only time we're going to go through one of these in this kind of gruesome detail to make this point, but since order doesn't matter, would it be okay for this problem if we multiplied the 3? Ooh. Okay, I don't know what's going on with you this morning, but we're gonna see if we can make that not blob quite so much. Okay, yeah, you can still see those. So could we multiply the 3 times the 2, call that 6, and then leave the other guy?
Yeah.
Okay, so I'm getting a vote for yes here, and we're going to prove this in a second. Could we multiply the 3 times the 2x plus 1 and call that 6x plus 3 squared, and then eventually multiply by the 2?
Yes.
Okay, I'm getting a vote for yes here. Which means if you agree I can do that with the 3, then you ought to agree I could do it with the 2. Put the 2 in there and then multiply by 3 later. Okay, so we're going to take a look at these. And we're going to see if we actually work these out, what we get, and we're going to talk about what we get. So the first one I'm going to look at is this guy. Right? Order of operations, cough, 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 which is where this goes bad, says, what are we supposed to deal with first? If you do the old, you know, I do this and then I do that, blah, blah, blah. Say again. Exponents and or grouping symbols of some sort, parentheses. Okay, so grouping symbols and exponents. Supposed to deal with those first. What's supposed to come second? Multiplication, division, left to right. And that means last is going to be addition, subtraction, left to right. Okay. So order of operations says when we do this 6 times blah, 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 I'm supposed to do the exponent first. It's inside parentheses and it's raised to a power. So when I do that, I do 2x plus 1, 2x plus 1. That's 4x squared plus 4x plus 1. And when I multiply that by 6, I have 24x squared, 24x, and 6. Now look at this guy. Order of operation says exponent first. So I've got 36x squared, 36x, and 9 multiplied by this 2 out here. which is 72x squared, 72x, and 18. And unfortunately, that ain't that. So one of those things is wrong. Either my arrow on the left side guy or my arrow on the right side guy. One of those things I wasn't supposed to do. Look back at this, because this is right. This is general power rule. Which of these two did I do something wrong that I shouldn't have done that messed up my answer?
That's only going towards the.
I thought it was the right.
Okay, so take a look at this guy versus this guy. And then we're going to go back to that cube and work it all the way out, see what the story is. That 3 and that 2, what power are they raised to? Back up there in my little oval thingy. Just the plain old 3 and the plain old 2. What's the understood power on that? 1. If I multiply the 3 inside those parentheses, what am I now saying about the 3? Is it raised to the second power in that answer? No. That's the problem with this. This is wrong. You can't do this stuff. You cannot take a number that is outside of a parentheses that is raised to a power and stick them inside the parentheses. Because now you're not just using 3, you're using 3 times whatever all that stuff is and squaring it. So that doesn't work. You can multiply the stuff that's not raised to the funny power, the 3 times the 2. Perfectly lovely as a 6. So this is a perfectly lovely version of the answer, but you cannot bring a number that's not squared inside a squared set of parentheses. That messes up your answer. And just to make that point, and like I say, this is the last time we're gonna work these guys all the way out. Oops. Let me get rid of my message here. Okay. So if you do 2x plus 1, 2x plus 1, 2x plus 1. Let's say we're silly enough to do this the long way. Then I've got 4x squared, 4x and 1 multiplied by 2x plus 1. So I've got 8x cubed, 8x squared, 2x, 4x squared, 4x and 1, or 8x cubed, 12x squared, 6x and 1. And notice that the derivative of that is 24x squared, 24x and 6. This is the correct one. This guy isn't. And it's because we brought something inside a square that wasn't squared. That's the thing you can't do. So you need to store away on these on these general power rule problems that if you've got pieces out here, you got something out here, you got something out here, and then you've got stuff kind of, and it's going to be in the middle, raised to the funny power, you can't multiply that stuff that's not raised to the funny power inside the parentheses that is. That won't get you the right answer unless one of those things happens to be a 1. But the chance you're going to be multiplying by 1 is slim and none. So that's the thing that's off limits, is this guy raised to the funny power. Any of the other crap you got running around in that problem, if you want to multiply it together, fine. Most of the time, you probably won't want to multiply it together. but there is a case where you probably do, and where people will probably want you to. And we're going to talk about that in a minute. And that page looks crappy, but I don't know any other way to do that except stick it all on the same page and talk about it. So does it make sense why we can't pull that inside the parentheses, raised to the funny power? Okay, because that's the thing people want to do. And that's the thing you can't do. Okay, so let's say that we have f of x is 5x cubed plus 4x squared plus 7x to the 10th power, which no way, no how do I want to work out the long way. Give me a break. Use the general power rule. Find me the derivative for that and just get the pieces and quit.
We're just gonna get the pieces.
Yeah, then we're going to talk about what you could do, what you can't do, and why you probably don't want to do anything. With this one, at least. Okay, so what's down in front? 10. And then you have 5x cubed plus 4x squared plus 7x now to the 9th, all multiplied by who x squared? 15x squared plus 8x plus 7. That's the derivative. If you wanted to multiply something together, you can't, as per our last discussion, haul anything inside those parentheses until you raise everything to the 9th power first. Well, that's dumb. We're trying not to do that kind of stuff. That's why we got general power rule. But you could, if you wanted to, multiply all this stuff together. And so you could say, okay, I have 150x squared, 80x, and 70. And then all that's going to get multiplied by 5x cubed, 4x squared, 7x, all raised to the 9th power. Perfectly lovely. Why do people probably not want to do that? A, you might mess it up. As soon as you say 10 times 8 is 18, you might as well not have bothered here, okay? What's the other, assuming you're not going to make a mathematical error reason? It's going to take time. Okay.
The exact same thing.
It's the exact same thing, except in this version, all of these numbers in the sort of singleton parentheses, if you will, are all what size in relation to the original answer we had. They're all big. People don't normally want to look at bigger numbers. They tend to want to look at smaller numbers. So yeah, you can do this, but you know, kind of, why would you want to do this? If I'm going to make things bigger, I don't normally want to do that. Also, I'm kind of hoping maybe later somewhere there's a division by 10 or a division by 5 or something. And so if I've still got that 10 hanging around out in front, it might be obvious that I could divide it off some way or something. So I don't really want to muddle it up with those other numbers and make everything bigger. It's not wrong if you do, but this guy is going to be the preferred version. the preferred version for this. In contrast to, let's say we have h of x is the square root of 8x squared plus 7, which is not at all unheard of for us to have derivatives of expressions under square roots, cube roots, fourth roots, the old weird exponent story from exam 1. What's the first thing we have to do with this kind of stuff, just like we used to have to do with the square root of x before we can take our derivative? And convert it to, okay, exponential form. So I'm looking at 8x squared plus 7 to the 1/2 power. Fractional exponents are the ones that take roots. Now, this is just like the other one. So I have exponent down in front. Subtract 1 from the exponent. So I now have 8x squared plus 7 to the negative 1/2. 1/2 minus 2/2, which is negative 1/2 times 16x, the derivative of what's in parentheses. I cannot multiply stuff inside with the weirdo exponent. He's just off limits. Back up here, I really didn't want to multiply that stuff together because it made all the numbers bigger. What's different here?
This will make it smaller.
Because what can I multiply together?
1/2 by 16.
And that becomes, and now I don't have a fraction anymore, which makes everybody on the planet happy because people don't like to look at fractions. And if you say half of 16x is 8x, and then you have this other thing, people are happy. So if you have a fraction out in front that's going to multiply nicely with the guy on the end, like half of 16 is 8, people tend to want you to do that. People tend to want to do that. But in contrast to something we're going to look at in a second, just because there's a fraction doesn't mean I want to multiply something. And we're not going to rewrite these so that they don't have negative exponents and blah. We're not going to fix that. That's not our issue now in using the general power rule. WebAssign's not going to ask you to rewrite the stuff. Difference between those, why I wouldn't want to multiply on the top one and I would on the bottom, makes sense. Don't make it deeper than it is, but it needs to, you need to go, oh yeah, that makes sense. So try this one. I'm running out of brain power to write letters here. Let's do the cube root of 5x minus 1 and do me the derivative of that guy. And then look at what you have and think about what you might want to do or might want to do and why or why not. Okay, so this becomes 5x minus 1 all to what power? 1/3. If the square root was a half, then the cube root is 1/3. General power rule, I've got 1/3, 5x minus 1, now to the negative 2/3, 1/3 minus 3/3, multiplied by. Now, I liked the one a minute ago because half of 16x was 8x. Do I want to multiply these here? I mean, I can't bring them inside the weird exponent thing. I'm going to quit saying that. We've already agreed we're not going to do that. Why might I not want to do this here? Do I get anything that looks better? No. I get 5/3. You know, 1/3 and 5, people are not real happy to look at 1/3. They get seriously distressed when you start doing this kind of stuff and you don't have to, because that's like an improper fraction. And then they want to make it a mixed number, God help us, or they want to do a decimal that they truncated or rounded in some. That doesn't help anybody. So if you like 5/3, go for it. But it also needs to make sense why this fraction I did want to do something with, because it's going to look better and people are all going to be happy. And this fraction, I'm probably not going to want to do anything with because it's not going to make people happy. And part of the deal, in case it hasn't registered yet, one of the reasons you do these kind of classes is you want to use some of these techniques once we have them to deal with word problems where you want to be able to communicate something to people about the answer. So you want to make it look nice and you want to make it easy to interpret and that kind of stuff. You want to pretty it up when you can, but you don't want to make things look worse for people. All right. I'm not going to say anything about these. I don't want you to go look stuff up somewhere. I don't want to hear a bunch of flipping of notebook pages while you're frantically trying to find something. It's not the goal. I just want to see if you remember, and I want to get you into the habit of taking a shot at stuff when it's not an exam. Because I've seen people who will just sit and stare at something like it's magically going to work itself. Hello. Leap off the cliff if it's not an exam and just try something. So let f of x be 5 over 6x squared plus 3x plus 4 to the 20th. Now, these are still general power rule problems. Just think about what you learned in exam 1. And then we're going to let g of x be, we're going to let g of x be 1 over the square root of 6x cubed minus 4x. And that's all under the square root. Just take a guess. And we're not using the quotient rule. Oh, Lordy, no. We do not want to mix quotient rule with this nightmarish stuff. So this is general power rule problems. And as a hint up there in the upper right corner, think about for exam 1, what you did for a problem like 1 over x squared, when essentially all you knew was the power rule. These are the same issue. Okay, so I've got my expressions with variables in them in the bottom of fractions here, like we used to have with 1 over x squared. What's the thing I ought to remember with exponents when that's going on? What kind of exponents should I be thinking about?
Which one?
All of these where I have variables in the bottom.
Your exponent's negative.
I need to remember that negative exponents are the ones that put things in the bottom. So for both of these problems, again, I don't want to use quotient rule, because remember, a quotient rule, I'm going to have to square this thing that's in the bottom, and I'm going to have to take its derivative as part of the quotient rule with all that other mess. I don't ever want to think about that. So I want to think about negative exponents with these guys, and then general power rule, just like I used to think with 1 over x squared. So for f of x, where I have 5 over 6x squared, 3x, 4, all raised to the 20th power. I'm going to want to think about that. This is the original. This is not the derivative. 5 times 6x squared plus 3x plus 4 to the negative 20th, because I brought it up from the bottom. That's what negative exponents indicate. Now, that's regular old general power rule. So what's the first thing I'm going to see when I start the general power rule? Negative 100, exponent down in front, there's already a 5 there, just like 3x squared became 6x, exponent hits on whatever's down there. So I'm going to have negative 100, blah, 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 now to the negative 21, I'm subtracting 1, times 12x plus 3. Derivative of stuff. Do I want to multiply anything together here? No. I mean, 100's not bad, 1200, 300, but they're still that much bigger. Who cares? And we are not going to rewrite these to fix the negative exponents and put the radicals back and all of that. You know, right? Yes, we could still do that, but for these, we don't care. Question, problem, issue, anything about that guy that's problematic? Okay. Who was this? This was G. Okay. So we have 1 over square root 6x cubed, oops, 6x cubed minus 4x. So we're going to rewrite that as what?
6x cubed minus 4x, that's negative 1/2.
Okay, I know it's to the 1/2 of some kind because it's under a square root, and I'm gonna bring it up out of the bottom. And yeah, there's a 1 in front, but who cares? Because if I bring that down and multiply by 1, I can write the 1, but I don't have to. I did when that was a 5 up there because I don't want to lose the 5, but oops. Okay, so I've got 6x cubed minus 4x to the negative 1/2 power. It's exponential form. So now it's general power rule. What comes down in front? Negative 1/2. Now I have 6x cubed minus 4x to the negative 3/2, negative 1/2 minus 2/2 times 18x squared minus 4. Is this one, I might want to multiply some stuff together. Yes. Why? Because I got a 1/2 out in front. It's negative, but who cares? I've got a 1/2 out in front. I mean, I care in terms of my answer, but I don't care in terms of my decision-making process here. I've got even numbers over there in parentheses. I've got an 18 and a 4, and 1/2 of those will be nice numbers. So this is one I would want to multiply out. And so negative 1/2 times 18 will give me negative 9x squared. Negative 1/2 times negative 4 will be plus 2. Now my fraction's gone, that negative out in front's gone, all of that's taken care of. And then I still have 6x cubed minus 4x all to the negative 3/2. And that has less stuff. And I don't have fractions inside my parentheses, which tends to make people happy. Question, problem, issue, something about that? Okay, so I'm obviously going to go home and upload the screenshots, upload the video. By the way, I don't know what was going on with Zoom on Wednesday. I started processing the video when I got home at like 11-ish. And it was 8:30 or 9 before it ever said, we're done. So I will start. Last night it was working like a charm, but who knows? So I'll do that. What's the other thing you bet I'm going to tell you is also going to show up sometime this afternoon?
Homework.
In
Website.
WebAssign, because we've now done enough of this that I can put some general power rule WebAssign problems up. When will they be due?
December 6th.
Like every other homework set. So, you don't need to keep sending me emails saying, I'm late on the homework. When's homework due? Check the calendar, check the syllabus, but December 6th, although you do not want to wait till then because you're using the homework to study for the exam, blah, blah, blah. Okay, question about something before we disappear.
So you got like, so you know how like the number, so negative 1/2 in the front.
Yeah.
So you can take that number and multiply by the root of the problem, but not like.
Yes, you cannot bring it inside anything raised to a funny power. But every other piece that's not raised to the funny power, that's raised to the first power, is fair game to multiply together in any of these. Anything else? Okay. Wednesday, where are we going to go Wednesday? Wednesday.